Okay, Andrew, it's about time to start showing how it fires up.
Okay. So I have my power supply here. It is quite expensive. It's purchased for another project. I'd saved up some time to buy this. It's an excellent power supply, which is capable of supplying quite a lot of power at very precise limits. So I can change on here, I can limit the current at an exact value, so I can reduce it or increase it at 1 amp increments or 0.1 amp increments. Same with the voltage. So it's an extremely accurate power supply. In this circumstance, the accuracy isn't terribly important, but if I were powering much more sensitive electronics, the accuracy is quite important. So here I have a positive and negative wire, which are connected to the back terminals here, which are capable of supplying the full 40 amps. The front output is for smaller projects, can only supply 5 amps as it says on the front. So I have those hooked up to the back. The red is the standard positive cable, and black is the standard negative cable for DC electrical components. So I generally start by hooking up the ground or negative wire, because the way that the switches work is once you activate them, they stay on until they're grounded. So here we have a wire grounding all of them. And then I'll just make sure that none of the switches have melted as did the previous one. I will tap it on the positive rail and make sure that the voltage and current don't jump. If they do jump, it means one of the internal parts of the switches have melted and I need to replace it.
So you need a constant testing.
Yes, so every time I turn this on I have to test it because they all have the potential to break at any time. So I've touched it and it's nothing is happening, which means everything should be working fine. So I connect it to the end here, and now the two rails are, this rail is live and ready to supply power.
So at the end of this, we have can you drive us through?
So here's the end of the map. I have made it reasonably flush to make it so for when it's finished in experimentation, I have a good flat surface to measure the distance from with high accuracy. Here, as we're just showing you how it works at the moment, that accuracy is really necessary, but we have placed a metal container with a weight in it, because it does fire with some force, can be enough to move this, so the weight is to stop it moving too far, and the container is there to stop it flying off and getting lost or potentially harming someone once which we don't want to happen. It's safe, reasonably safe. You can put your hand in front of it when it fires, but if it does bounce off of something, ricochet, and it goes into someone's eye, there is the potential to cause damage there.
So you have considered all the ethical
yes.
issues, harming, yeah. Okay.
So I would be confident to someone put their hand there and shoot that. You can feel a gentle flick, but obviously you want someone to flick you in your eye. That could cause damage because it's a nail that's far more dangerous. So I've got
okay.
that there.
So now we're trying to see if it will reach a distance of 50 centimeters after the last coil.
Well, it's after the last coil, which won't be used, so it's actually got to go through about 90 centimeters from here, so it has to make it through the tube, and then an
another
additional half meter or so after that. I have done some test firing before. The furthest I've ever had it shoot something is about 3 meters.
Okay.
So it should be able to do this. Of course, there is, as I mentioned, the possibility that it will fire backwards in that direction, but that shouldn't cause too much of an issue. I don't have anything to capture it there, but there's no one on that side of the room.
So we have made sure that it is safe.
Yeah, so there's
Nobody.
there, and the door there is locked, so nobody can come in and have it hit them.
Okay.
So it should be quite safe. So I need to, quite a jumble, so most of my issues have been here, so I've got quite a tangled mess of wires, so I can find the one that's labeled 1, because we're activating this core, and I found it there.
So we need to clarify that once you solve your electronics issue, that will be firing.
Yes, it will be firing with all the coils, and then I'll just be doing some timing issue.
Yes.
So once I've solved that problem, I will be setting this up so it's not a horrible mess.
So it will be fired electronically. Yes, that's what you're
It
saying.
will be fired electronically.
Great.
So manually, because it works when you touch it, I'll just be touching it with my hand.
And we saw the difference there. Yes.
Yeah. So it didn't come out. So I have to lift the front end up and wait for it to slide back to the original starting position.
Have you sensed it? Is it out?
Yeah.
Great.
So it's now at the very end of the
Great.
flush with the end.
So I'm keeping the distance.
Where it should be. I'll just modify this a little bit because it doesn't quite need to be pushed up there. So here we'll try it again. Last time it got stuck around about there. It's testing. So, no, okay. It's gotten stuck in the middle again. It's very troublesome. It's sometimes.
It is the point any scientist is confronting. Trial and error and repeated. Yes, don't worry.
Lots of trial and error. We may cut out the next 1,000 failures that it has and maybe put them in a blooper reel. Okay, so here we may have damaged something because now when I touch this we get
Yes, there is a problem. So we can always do it again. Don't worry about this.
Yeah. So